Ja, men då är hela uppvärmningen och splittrar och sådär. Ja, det har vi gjort. Du, vad hette den där basnivån? Regn bryta alltså störande ljud och folk pratar som ska ha lite lugnande fågelkvitter och vågor och man rasar jag provar det. Jag skjutsar lurar
det blev inte
All right, so I guess I'll get started. I hope everyone's not too sleepy after heavy lunch. My talk is the 12-factor app, best practices for JVM deployment. But I considered giving this a different title, that being Java doesn't suck if you do things this way. I think Java, the JDK, the JVM have developed a reputation for just kind of sucking in the broader software community. I don't think that's true. I think Java's great, but I don't think Java sucks. But our friends that work on other languages have asked me, why do you return to Java after working on so many other things? And it's because it's a great platform. But we continue to use it in a very old-fashioned way. We need to update our techniques, update our approaches to both development and deployment. Things like XML sucks, 10-page wikis to set up your app, which really only happen in 3 simple steps. That sucks. Incongruent deployment environments, where your dev environment is not identical to your production environment. That sucks. It sucks because it makes it difficult to do development work, but it also makes it difficult to reproduce your environments. I'll talk more about that later. Apps that take more than 30 seconds to start up suck. It makes it difficult to scale. It makes feedback slow. Recompiling your entire code base after a typo sucks. Monolithic apps suck. Java language, pre-Java 8, it kind of sucks, right? But I think Java 8 is great. If you went to the Streams talk or saw a keynote this morning, I think there's really exciting things happening in the newer versions of the language. But there's also Scala, Clojure, JRuby. These are very mature languages now, and they're perfectly production ready. And as Ula said yesterday, polyglot programming is the future. So picking the right tool for the job is possible on the JVM platform without sort of giving up all the power of the JVM. So Java does not suck. It's the way we're using it that sucks. We need to become more modern. And so that's really what I'm going to talk about today. What does modern Java development, modern Java deployment look like? So before I go any further, my name is Joe Kutner. I go by Codefinger on IRC, Twitter, the internet. And I work for Heroku, where I'm the JVM languages owner. So Heroku is a cloud-based platform as a service. Makes it easy to build, deploy, and scale your applications without managing any kind of infrastructure, even virtual infrastructure. And I support all of the Java languages, make sure that they not only run well, but also that they sort of align well with the Java ecosystem. So when you're deploying a Java application, it doesn't feel like you're deploying a Ruby application. Heroku had its roots in Ruby. It started as a Ruby pass. In fact, some would say Heroku sort of invented the concept of a platform as a service. But it's since branched out. And so every day I see literally thousands of applications being deployed. Some that work, some that don't. I mostly see the ones that don't because those are the ones I hear about. And at Heroku, we've sort of taken the ideas that we've seen that work and combined them into a methodology we call the 12-factor app. So this is the combination of a set of best practices, a set of principles that allow applications to be successful, to be scalable, to be maintainable, and ultimately to be even portable across other cloud-based platforms as a service. So these are its goals, but really what that ends up giving you is the ability to do continuous delivery. And continuous delivery is important because it helps you sleep better at night. I find that there is a high correlation between continuous delivery and sleep. The worst place I worked at, we were deploying in 2-week cycles on a Thursday night, and I could pretty much guarantee that I was not going to get any sleep on Thursday night because something would go wrong, something unexpected, and just cause trouble that keeps you awake. But on Heroku, we find that most people are deploying multiple times a day, and as a result, their applications are designed with this in mind, and it makes them more resilient to that kind of deployment. So these are the 12 factors. There's sort of a heterogeneous mix of best practices, aspects of development, aspects of deployment. Some of these, because this is a language agnostic methodology, really applies to Ruby or Java or whatever, some of these are areas where the JVM and Java development does really well, things like concurrency. But that's not always true. Some of these are areas where the JVM suffers. And so those are the ones I'm going to focus on today. I won't necessarily talk about every one of these. The one I'd like to start with is disposability. Disposability is a principle that states your application should be quick to start up, graceful to shut down, and resilient to failure. So they should be quick to start up. They should take ideally less than 30 seconds between starting and binding to a port and handling requests. That's important mainly for scalability, to be able to scale quickly and increase your capacity for higher demand. But it's also important for deployment cycles, releasing new versions of your application. If the application is slow to start up, it makes continuous delivery difficult. Likewise, it should be graceful to shut down. It should not leave any residue behind. And it should not take any state with it, so we encourage stateless processes. And of course, it should be resilient to failure. If a node in your architecture goes down, it should not affect the other nodes. And you should be able to replace that node very easily, partially because it is quick to start up. So a good example of non-disposable applications, one is actually the Minecraft server, which I cannot get that thing to shut down cleanly. But in a more professional context, I worked for a company that was deploying a WAR file into an application container, kind of standard method. And it took several minutes for the application to start up, between actually getting it out there, updating the application server, and then handling requests. And that doesn't seem like a big deal of a single node, but when you're working with dozens of nodes, a full deployment with rolling restarts can take hours. And of course, that causes losing sleep. So I would argue that application servers are not disposable, just in their nature. They're a piece of infrastructure that our applications rely upon that's external to the application itself. If the application server isn't running, your application is not running. On the other hand, microservices are disposable. So microservices are an architectural pattern where you decompose your application into lots of small services, some would say as small as 10 to 100 lines of code, and then compose a larger application out of those services. Now this is not a microservices talk, and I'm not going to strongly advocate for microservices, but there are aspects of this methodology that you can take away without implementing a full-on microservices architecture. And among those is the fact that these microservices are easy to replace, they're easy to modify because they're small and compartmentalized, and they're decoupled from external infrastructure, which makes them disposable. They don't depend on other aspects of the system to be up and running for them to go about their job. And one of the companies that's strongly embraced microservices is Netflix, and they've shared their interesting architectural, I guess you call it architectural diagram, which is the spaghetti mess of interconnected nodes, right? So that's a downside to microservices, but the advantage of this is that it allows them to deploy independent components of their application without bringing the entire application down. So for example, if they want to deploy an update to the system that allows you to rate movies, no one has to stop watching their movies to do that. So it gives them what is effectively true zero downtime deployment. And many other shops are doing the same thing. Twitter with Scala, Gilt also with Scala. Gilt's an interesting example because they sell clothes. They do these flash sales where for a very short period of time, they have deep discounts on a particular hot piece of socks or something, I don't know. And in anticipation of that, they'll scale up to very high capacity, have the flash sale, and then scale right back down after it, returning all those no longer needed instances to the cloud so that they're not paying for them. And they can do that because their services are disposable. So the key to disposability is the standalone nature of these microservices, and that's, I think, really the thing to take away. If the small application, or whatever your application is, can stand alone by itself, be run by itself, in many cases as an executable jar file, that allows it to be disposable. The other characteristic is that they're bootable. So these microservices can start up on their own. They don't require containers to keep them running. Okay, so that's disposability. The next factor I'll talk about is dev prod parity, which I alluded to at the beginning of the talk. This is a principle that states that your development environment should be identical to your production environment and to every environment in between. The most common place that we see this violated is at the database layer. If you're using Postgres in production, you should be using it in development. Not only because it prevents the introduction of bugs that would only appear in later stages of development, but also because it allows you to reproduce your environments very easily. We also see this violated at the container layer. If you're using Jetty in production, you should be using Jetty in development. Or even better, don't use a container. Jetty can be embedded into your application to create a standalone executable app. So let's talk about that for a moment. The traditional method of JVM deployment is take your code, compile it, package it up into a WAR file, and then drop that WAR file into a running container. And this was great in 1999 when it was introduced in the servlet spec, but that was a long time ago. That was a time before the cloud. It was even before virtualization. At the time that WAR files made sense, most of us were deploying applications to a piece of metal running in a closet down the hallway. Whereas today, you may still be doing that, but even that platform is virtualized. So many of the advantages that Tomcat gave us are replicated by other technologies. So modern JVM deployment looks more like this. You compile your code, package it into a jar file that contains everything your application needs to run, and then you deploy that thing anywhere. It could be in the cloud, it could be on Amazon, it could be on your local dev box. Because it has fewer dependencies and does not rely on that external infrastructure, it's ultimately more portable. You can deploy this executable jar file anywhere that you have a JVM, theoretically. So the key to parity is really about reproducibility. If your application is more portable, if it's decoupled from infrastructure, it's easier to reproduce a development environment in the same way that you reproduce a production environment. This reproducibility is also ultimately what leads to disposability. Because if you can replace a crashed node in your architecture very easily, that comes from the reproducible nature of it. All right, so the next factor is configuration. Configuration should be strictly separated from your code. Configuration belongs in the environment, not in the application. So we have this problem in Java development that I call configuration proliferation. We have configuration in our application, in our web XML, in our Tomcat container, in our operating system, just strewn about all over the place. And it makes it difficult to reproduce the environment required to run our applications. I worked at a place once that had a configuration management suite of Chef that was almost more complicated than the actual application that they were trying to run. So in the 12-factor app, we promote that all configuration be separated from the application and stored in the environment specifically as environment variables. After all, that's what environment variables were meant for. Everything from your database URL to your Amazon access tokens to the options used to start your JVM. They belong as part of the environment. If your staging environment has additional memory, that would be part of your Java options. So let me tell you a story about something bad that happened to me once. Working with a company deploying a WAR file that contained JDBC connection information for all environments. And depending on the environment, it would connect to a different database. And we deployed to staging. Something was wrong and it connected to the production database. Now, there's an IT problem there that it should have been able to do that, but ultimately, when we started testing it, we created all kinds of problems. But ultimately, it should never have even tried to connect to that production database, because the database URL should have been part of that staging environment. The staging environment should have been contained to what made up the staging database and staging servers. So the key to separating this configuration is really about going containerless. Separating your application from that container, from that infrastructure that needs to be configured. If you have no container, it reduces the amount of things that need to be configured. Containerless is also, as we saw, key to parity. So easily reproducing your application requires reducing the different infrastructure that it depends on. And ultimately, it's what leads to disposable apps as well, because it allows them to be bootable and standalone. So if I could describe the 12-factor app in one word, it would probably be containerless. And I think that's the key to modern Java development and deployment. That's certainly what Netflix, Twitter, and Guilt are doing, but it's also what major application frameworks are doing. Spring with its Spring Boot project, instead of deploying your Spring application into a container, it embeds Tomcat for you. The Play framework does this as well with Netty. Finagle from Twitter is containerless. Drop Wizard is containerless. Ratpack is containerless. All of the modern frameworks are embracing this approach. So what does this look like? If you're using Spring, it's not terribly complicated. For Spring Boot, you pick one of your classes as the entry point to the application. You give a public static void main method, and you start the Spring application in that method. It then handles for you all of the booting up of Tomcat and binding to a port. Those become dependencies of your application, sort of inverting the model. But you don't have to use Spring Boot. You can embed Jetty directly. The same kind of approach. Public static void main method. You instantiate the server, you start it, you configure it, you join to it. Not too bad. If you're using Clojure, there's some great bindings that allow you to do this in just a line of code or two. And if you're using the Play framework, you don't have to do anything. It just works this way. And that's what these frameworks are trending towards. There's no more setting up of that infrastructure. It handles binding to a port for you. All right, so I will show you what this looks like. All right, so I have here a very simple Spring Boot application. Just a single controller, a POM file, an HTML file. I run Maven against this. Compiles my code, packages it into a jar file along with all the dependencies needed to run my application. So if I look under the target directory, there is that single executable jar file. And I can run this jar file with a simple Java command. So its only dependency is the JVM itself. And when it starts up, I see Spring start up. I see Tomcat, the embedded Tomcat start up. It binds to a port and it's ready to go very quickly without any other dependencies. So I can take an application like this that's bootable and standalone and very easily deploy it to a platform like Heroku. So Heroku provides this Heroku tool belt, which gives you some command line options for creating and managing applications. So if I run Heroku create, this will provision a new Heroku application for me in the cloud. It also provisions a remote Git repository for me. So my code is under Git version control. So I can then push to that remote Git repository. Heroku will detect that I've pushed to that repository. It'll detect that I have a Java application because it has a POM file. It'll then run the same Maven process that I ran locally, generate the jar file, package the jar file in the JVM into an application image, very similar to a Docker image, and then start that application. So once the deployment is finished, my application is already started up and running. And I can see that by running Heroku logs. You can see there's Spring Boot starting up at the end of the log file. And I can open the application. Heroku open. So what this application actually does is unimportant, but you can see it there running on Heroku just by pushing to a Git repository. This command line tool also provides some other features, such as Heroku releases, which allows you to see a history of deployments of your application. So each time you git push to the Heroku repository, a new release version is created, and that image that contained your JVM and your jar file is retained. So if you deploy features that break, you can easily roll back and then debug in a separate thread. So again, all of this is designed to make continuous delivery easy. There's a few other things you can do with this. You can run Heroku PS to see the status of your process. So there's the Java process, one instance of it running, it's up. And then you can use Heroku PS scale to quickly create more instances of that application. So there you can see the 4 new instances starting up. And Heroku will take care of the load balancing for all of these processes within the same app. And then you can scale back down just as easily by setting web back to 1. It'll dispose of those other instances and scale your app back down. So I'm running Java 7 locally because I'm old school, right? But Heroku provides the Heroku run command, which allows you to run commands on the Heroku servers in the context of your application. So I can use Heroku run Java version to see that I'm actually using Java 8 on my production servers. I can also use Heroku run to start a bash prompt from my application environment. So you can run multiple commands. This is good for running one-off tasks, database migrations, that kind of thing. So you can see there's the Java and all of my compiled assets are there too. Now everything I was doing from the command line can actually also be done from the Heroku dashboard. So this is the dashboard for my app. You can see the Java process running there. You can scale it here by just moving this slider up and down. This is doing exactly the same thing as the Heroku PS command. When I create new instances of the application, that changes my run rate, the price I pay per month. But it's important to note that Heroku is free to use for one application instance. And then that's great for sort of proof of concepting an app, and then as you scale beyond that, as you need more capacity, then you start paying us. Something like 90% of Heroku's users are using it for free. You can view activity, which was equivalent to the Heroku releases command. You can control access, give other developers the ability to push to this repository. And then I think this is pretty cool. You can get a sort of coarse-grained view of the metrics for your application. Response time, throughput, CPU usage, and memory. And it'll report any request timeouts and things like that, so you can start to correlate those to spikes in CPU. All of this with no additional code. This is just provided from our platform. We have additional plugins that allow you to add on New Relic support for more fine-grained details. All right, so that's what a 12-factor app looks like. But I think there's a little bit of, I lied to you a little bit. There's still a container. So this is a containerless app in the sense that there's no Tomcat. The Tomcat has been replaced essentially by Heroku. Heroku is a container in the same way that Docker is a container. It's a virtualization platform, right? So it's not that we're doing away with containers altogether. We've just replaced that functionality with something else. Again, this is a modern context. Tomcat was created before the web, or before the cloud, before virtualization. And now we have new and, I would argue, better tools for that. All right, so the next factor is concurrency. As I said, concurrency is an area where the JVM does really well. You know, we have native threads and all of that, so we can scale up very well. We can throw memory and CPU at the JVM all day long, and it does great. But we also need to be able to scale out, both in creating new instances of our applications, but also in diversifying our workload. So decomposing the different parts of our app into separate apps. So you could say that I'm talking about microservices again, or you could not, whatever floats your boat. But the idea here is that if you need to handle more web requests, if you need to scale that part of your application, you should be able to do that without scaling the part that does background workers. Likewise, if you need to do more background working capacity, you shouldn't have to scale your web processes to do that. So scaling out in this way is just as important as scaling up. The next factor is admin processes. So admin processes, things like database migrations and one-off tasks, should be run in isolated processes. This is important, I can speak from experience, because if you log into a production server to run a particular job, you have the potential to crash the Java process that's actually serving your website. I've done that. So when I ran the Heroku run command and started a bash terminal, what I had done was instantiate a new instance of my application, an entirely new, separate, isolated container that had all of my application binaries, just as I did with the Heroku PS command. The only difference was with the Heroku PS command, I told the app to start up and bind to a port and start handling requests. When I executed Heroku run bash, I got the same type of instance, I just hadn't started my application. So it gave me this highly isolated environment that was identical to the other environments. All right, I'll just skim over a few more of these factors. Code base, if you're using version control, you've pretty much got this one. Like, you should have a single code base, and you should deploy that code base. Dependencies, if you're using Maven or Gradle, you've got this covered. Although I do see a lot of apps that are using Maven, but will still pull in manually generated jar files and just, in some cases, drop them into the Git repository. That's really bad, because you can't version those. You can't control those dependencies in the way that Maven allows you to manage that. Processes should be stateless. If you are dealing with session state, you might be using sticky sessions, but in the 12-factor app, we promote that you push that session state out into some kind of external store to make your applications disposable, so that if a node goes down, it doesn't take someone's session state with it. That's important for scalability again. All right, so I'm going to give you a to-do list. You now know about the 12-factor app. Congratulations. But what do you do about it? I'm going to give you 3 things that I want you to do with your applications when you leave here. The first is make sure you can set up and get your application running in 3 steps. So pretend that you are someone new to your company, you've just started working on the app. You should install the JVM, clone the source code repository, and run the app. That should be all that's needed to get up and running. If you're using a database or something like that, you can provision that on Heroku, connect to it remotely just to get started. So there's potentially those pieces of infrastructure you need can be based in the cloud, even for development. You should make your application start up quickly, and I mean this very literally. Get a stopwatch, start your process, and see how long it takes before it binds to a port and starts handling requests. And then strive to get that under 30%. In many cases, you can find background work or work that should be in the background that's being inlined at boot time to either migrate the database or do something like that. See if you can move that into the background. Some application frameworks just start up slow because they load lots of plugins, Grails in particular. Maybe that's an indication that you need to decompose a more monolithic app into many apps that do specific jobs and start up very quickly. You should be able to deploy or scale your app in one step. So not only deploy a new version of it, but also provision a new environment, deploy the app into that environment, and start handling requests in a single step. That's really what I was doing with the Heroku create command and then the push to the Git repository. And if you don't use Git, that's fine. We actually have a Maven plugin that packages up that application image that I'm saying is like a Docker image locally and pushes it up to Heroku, so you don't even run Maven on the Heroku servers. You can do this with a executable application. You can also do it with a WAR file. So yeah, we do support WAR files. This talk is promoting, getting away from that, but it's definitely something we support. When you deploy a WAR file, we provide a Tomcat container for you. You can learn more about the 12-factor app at twelwefactor.net. Again, this is a language-agnostic platform, so it's a language-agnostic methodology. So it applies generally to applications of all kinds, especially all of the JVM languages. And I think it's important to remember that Java doesn't suck. It's just you that sucks, and the way you're using it. No, not really. It's a great platform. And I've left Java for years. I worked on Ruby applications. And I've come back to it because it is an excellent piece of software to work with. I would argue one of the best pieces of software that the industry has. I am Joe Kutner. I go by Codefinger, as I said. And the slides are, if you can see that, are online. But if you just follow me on Twitter, I'll tweet out a link to them later on. Thank you. Any questions? Too? Yep.
So when you propose that you should have containerless applications, do you propose that you should stop use the Java EE components such as those other bases and object relational mapping and enterprise beans?
Yeah, so many of those components can be pulled in as libraries as well. So I think we're used to having the application container provide that for us. But again, that becomes an external dependency that's not managed by your application. And that's what I think we need to move away from, is that if you're using an object relational mapper or any of these enterprise things, you should be pulling those in as part of your standard build process.
What are your views on those components in themselves? Is a good way to build applications?
For like what's a specific example that you're thinking of?
Those three enterprise beans and the JPA and the Java server bases.
So yeah, you can still use those without the container providing them for you. So that's the approach. You know, include them as dependencies. Yeah.
And do you struggle with, or Heroku, I should say, struggling with any of this extra much, or is it some part that you find more difficult of doing that?
I think, yeah, there's some big paradigm shifts, right? But mostly, the applications that we build are based on things like the Play framework and Finagle. So when you're using a framework like that, it's not a problem simply because it provides a different context for you. If you're deploying into, if you're starting with a traditional environment and moving towards, like Spring Boot or something that's a more gradual step, that's something that more our customers are dealing with. And yeah, we've seen, I'm trying to think of the most common kind of problem going towards this. The session state was one of them. So many of our customers expect that they'll be able to use sticky sessions, which they can, but it ends up, especially if you're scaling up and down very often, that ends up being problematic. So we encourage, the use of Redis or Memcache. But the Heroku platform provides those caching mechanisms for you, so you don't have to set them up yourself. Again, there's no reliance on external infrastructure or even managing the infrastructure at all. Yeah. All right. Thank you.
Process.